So how would you find, towards the end of the semester, you're going to have some calculations you're going to be playing with. How would you find the average of your 4 test grades? You don't. Add them up and divide by 4. Good. So, but what happens if you have an infinite number of things to add up and divide? So, add them and divide by infinity. That might take a while. So, what's going to happen when we work with functions like f of x is the square root of x on the interval 0 to 4 is where we want to find an average value. Well, square root of x takes on an infinite number of values between 0 and 4. In fact, the graph of that is on that link that I sent you right here. So, what's the average value? Well, that's a good question. Is it problem 2? It's problem 2. Yeah, I wrote problem 4 up here, but it's actually problem 2. So there we go. Thanks. So to find the average value, we have to kind of add all these up and divide by something. Well, if you're trying to think of this in terms of maybe a discrete set of things, like we did with finding areas initially, what we did was we broke it up into little intervals and tried to add more and more intervals to find the area underneath this curve. Well, finding the average value is going to be kind of similar. What we're going to do is we're going to find this area between 0 and 4 and between the x-axis and the curve, and then divide by the length of that interval. So what's that going to look like for us here? So overall, the average value is going to be 1 over b minus a times the integral from a to b of f of x dx. And that's going to be our average value. Average value. Okay. In our particular case, that's going to be the integral from 0 to 4 of the square root of x dx multiplied by 1 over 4 minus 0, or basically 1/4 of this. So 0 to 4. I'll probably rewrite that as x to the 1/2 to make my life a little bit easier. Integrating this, I'm hoping, is pretty old hat by now, right? So that'd be x to the 3/2 divided by 3/2. And divided by 3/2 is like multiplying by 2/3. So that's going to be 2 over 12 times, 1 over 6, x to the 3/2 between 0 and 4. So 1/6 times 4 to the 3/2 minus 0 to the 3/2 again, but it's not going to matter. 4 to the 3/2 is going to be 8. So 8/6 or 4/3. So that's the average value of the function. On average, if you were to look at this function between 0 and 4, its average value is 4/3. That's kind of an interesting point to come up with. Let's take a look at it geometrically and understand something else about that point. So here's that point right here. And let's just make this a little bit easier to see. There we go. So there's your average value. And it makes sense. I mean, there's a lot of values below here, but there's some higher. It's not exactly in the middle here, but that's okay. That's because there's some values pulling that up away from this middle value. But this also gives us another way to find this area. If I had the average value for the function, then instead of finding the area between 0 and 4 underneath this curve, I could replace that with finding the area of this rectangle. This is the same area. So that's kind of cool. Both of these have the same area. Nice. Ooh, right? Cool. So let's do that again. find another average value. We'll do it for problem number 12. So I'll shut these off, and we'll work on problem number 12. And let's zoom in here a little bit. So problem number 12. Y equals 2x e to the negative x squared. I think the interval is 0 to 2. Is that right? Let me just take a look here. Yeah, 0 to 2. That's our interval. So one of the things we're going to need to do is we're going to need to integrate this function from 0 to 2 of 2x e to the negative x squared dx. I'm kind of intentionally forgetting something here. What am I forgetting? Yeah. I got to multiply by 1 over the length of the interval. So really, that's like dividing by n, but we're doing it in the continuous case, where we've got an infinite number of values between here, so we're just going to divide by the length of the interval. Okay. So 1/2 the integral from, let's see. How are we going to handle this integration? That doesn't look like one of the basic forms that we're familiar with. Oh, yeah, U substitution. So for the benefit of my viewing audience, everybody is enthralled right now about the prospect of doing a U substitution. What should I let U equal? Negative x squared. So, well, what next? Tyler, some help? All right. du over dx equals negative 2x. And du equals negative 2x dx. Now, we have pretty much all of that in our integrand, right? So let me rewrite this as, let's see, e to the negative x squared, 2x dx. So the only difference between what I have here in the integrand and what I have here is the negative sign. Yes? The intervals? I'm going to. I just haven't got there yet. Yeah, I'm just finishing up the U substitution. So, but yeah, I like changing the intervals, and we will do that. If I divide both sides by -1, I get negative du equals 2x dx, and these are the same. This and this are the same. So I can replace this by negative du, and I'll substitute in here and get u. Now Brandon wants to help me change the intervals, so let's go for it. U of 0 would equal what? 0. How about u of 2? Negative 4. Negative 4. So, okay. I think we've got everything we need here. So it's going to be 1/2. And I get the intervals here are still 0 to 2. I haven't done my U substitution, but now that I do my U substitution, it's gonna, I have done. Did do. Do. All right. All right, so from 0 to negative 4, 0 to negative 4 of e to the u times what? Well, I got a negative du, and I'll show you a little trick. If you're bothered by that little negative sign there, I mean, I certainly would pull it out front at the very least. Minus 1/2 the integral from 0 to negative 4 of e to the u du. And it's a trick that I haven't really shown you, but I think you can kind of appreciate it. Remember when we're all done, when we find the antiderivative, you end up subtracting, the function at negative e to the negative 4 minus the function at e to the 0. If I switch these, if I flip the order from negative 4 to 0, that changes the sign of my integral. So I can get rid of that negative sign by changing the order here.
So your A and B, shouldn't the lower value one be
No, you're just following along with what we did when we changed our limits of integration. That's, it's from here to here in terms of u. It was from 0 to 2 in terms of x, but from 0 to -4 in terms of u. It's a different variable, so just go with the limits. Now I could work with it here, there'd be no problem, or I could work with it here. They're equivalent. When you swap the order of these, it changes the sign of your integral. As far as this one's concerned, what's the antiderivative of e to the u? E to the u, right? Between -4 and 0. And let me write it like this: 1/2 e to the u, -4 and 0. I like to put the constants out in front and just kind of keep them out front. So it's going to be e to the 0 minus e to the -4, which is 1 minus 1 over e to the 4 times 1/2. So this is the average value. Now I want to show you a little mistake I made at one point when I was working on this. And I caught it pretty quickly. But let's see if you can see it. So I'll need to calculate 1 minus 1 over e to the 4th. So that's here. So I got this bar here at y equals 1 minus e to the 4th. What's wrong with that being the average value?
It's like not even in the area.
Yeah. I mean, none of the y values even come close to that, right? So it can't be the average value if it's higher than all the values. So I remember, I don't know who it was, but I remember a politician saying, we're going to work towards making it so that everybody makes above the average wage. Well, you can't. Somebody's got to be below and somebody's got to be above. You can't all be above the average wage. So something similar is going on here. This is above like everything. It can't be the average. So what did I do wrong?
You didn't multiply by 1/2.
Yeah, I forgot to divide by 2 or multiply by 1/2. So there you go. That looks a little bit more reasonable. And finding the area underneath this curve and dividing it by 2 would be the same thing as finding the area here. They're equivalent. So, okay. How are we looking on that one? Good? Sweet. All right. Enjoy section 6.5.